Hello everyone, welcome to Parthiva Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 30th June 2023. The problem statement for today is binary number multiple of 3. Let's now open this problem to solve it. Let's go through and read the problem statement. Here it says, given a number in its binary form, find if the given binary number is a multiple of 3. It is recommended to finish the task using one traversal of input binary number. Okay, so the problem statement is saying that we will be given with a binary form of a number and we have to check whether that binary form is divisible. The number in the binary form is a multiple of 3. Okay, so that simply means that can we divide that number by 3 or not. Okay, so if you look at this if you look at the given examples here associated with this, then here it says the first example says that string is 0011. So here the output is 1, because if we convert this 0011 to decimal format, then we can see that this number is 3, which is divisible by 3. 3 is divisible by 3. When we look at the second example is 100. So if we change it to decimal form, then it is 4. Actually it is 4. So 4 is not divisible by 3. That's why the output is 0. So when we look at the problem statement and both the examples, so it might look very tempting that we need to just convert the given binary form into decimal and just divide it by 3 and check whether if it is divisible by 3, then the output is yes, else output is no. That means 1 and 0 respectively. So with that, the code for this will be something like this. Actually, I'll show the problem with this approach. Let me move to Java editor. So this one. So what we are changing here, whatever is the string there, we are converting it to decimal format, and we are checking that is the decimal format number is it divisible by 3 or not. If it is divisible by 3, then we return 1, else return 0. So when we try compiling it for a smaller input, it will run perfectly fine. For example, this is the given input here, 0011. See, here we have got correct output. Even if you try the another input which was there like 100, which was 4, it will give you 0. See, it is giving 0, which is the expected output. So this is working fine for the smaller input. But suppose if this that string in the binary form, if that is very large, then this form will not work. Okay, for example, if I take this example and I try to paste it in custom input, this one, if I try to compile this code, then it will give some problem, saying some number format exception, because this here it is here also we can see it is saying that input is too large. So this much big string number that is in the binary form, that cannot be converted to integer using this way. That's why it will not work for this much big input if that binary form is given in that string form. So for that we need to find some another solution. So here one better approach I have followed, that is based on the observation that a binary number is divisible by 3 if and only if the difference between the count of 1 digits at its even and odd positions is divisible by 3. Okay, so the count of ones which are there in even position and count of 1 which are there in odd position, if you take the difference, if that difference is divisible by 3, then we can say that the binary number is divisible by 3. Okay, so with this example, let's understand it in a better way. I've taken 3 examples here. If we look at this one, 101010, so here we can see that 1 at even position, that is 3, that is this one, this and this. So if you count them, then it is 3 in number, and 1 in odd position, that is 0, because we cannot find. See, here we are starting from the rightmost element, that means the least significant one. So we are taking the first one, first 0, that will be at place value of 1. So that is at odd position. So here we can see we do not have 1 at odd positions. So the number of ones at odd position will be 0, and number of 1 at even position will be 3. So 3 minus 0 will be 3, which is divisible by 3. That's why we are getting output as 1. But if you consider the second example, then here we can see this is at the rightmost one, that is at odd position. So here at odd position it is 1, then here, then this one is at odd position, then at 2, count is 2, 3, 4, 4. And if we count at even position, then it is 1, 2, 3. So here the difference is 1, which is not divisible by 3. Okay, that's why the output is 0. But if you are adding it one more, that means one extra one there, then here we can see then it is becoming the output as 1, because if we count the number of 1 at even position and subtract the number of ones at odd position, so that will be divisible by 3. So if you count this, then you will get then the difference as the number which can be divided by 3. That's why the output is 1. Okay, so based on this observation only we will be solving this problem. So I'll first remove this code because it won't work for all the test cases, especially when the input is too large. So with that advanced that better approach, I have prepared a solution. I'll just copy it here. I have even given comments against each line so that it becomes easy in understanding. So what we are doing here, we are initializing odd count and even count variables to keep track of the count of one digits at its odd and even positions, okay, respectively. Then traverse the binary string S from right to left. Right to left means starting from the least significant bit. So that's why we are taking the value of I from n minus 1. That means we are starting from the rightmost element. For each character in S, we check if it is equal to 1. If it is, then increment the count of either odd count or even count based on the position of the digit. Okay, if the position is even, then counting from the right starting from 1, increment even count. If the position is odd, increment odd count. Then after traversing the entire binary number, calculate the difference between even count and odd count, that we are getting here as diff. Then whatever the value we get in this variable, that we are checking if that number is divisible by 3 or not. Okay, if the difference is divisible by 3 and that means the remainder is 0, then we return 1. This indicates the binary number is divisible by 3. But if the difference is not divisible by 3, then we return 0. This indicates the binary number is not divisible by 3. So if we follow this approach, then here we do not take any overhead of converting the string to binary form through using integer.parseInt. Here just a one time of iteration through the complete string, and there we are just counting the numbers. So even if the input is too large, it will work for this for this solution. But the only thing we have to keep in mind that how the solution is based upon. This is based on the observation that a binary number is divisible by 3 if and only if the difference between the count of 1 digits at the even and odd positions is divisible by 3. Okay, so let's try compiling this code. So see, even for this big input, this time we have got the output as the correct output. It has not given that number format exception that it is unable to change that number to decimal or all those things. Whatever the error we got in the previous attempt, this didn't come this time. Okay, so with this code, let's try submitting the solution. So here we can see it has covered all the test cases. So this problem has been solved successfully. So this is the correct approach to solve this problem. So when we talk about the time complexity of the solution, it is in the order of big O of n, where n is the length of the binary string. This means that the time required to determine if the binary string is divisible by 3 increases linearly with the size of the input. What we are doing in this solution, we traverses the binary string once, performing constant time operations for each character. Therefore, the time complexity grows proportionally to the number of characters in the binary string. In other words, we can say if the binary string double in length, the execution of the solution will also roughly double. The linear relationship between the input size and the execution time gives us the solution in a time complexity of big O of n. Okay, so this was a Java solution. Even I have prepared C++ solution. The logic is completely same. Here we do not have any significant difference between the solution. Here the way only we access the characters in a string. Here in Java we use caret function, and in C++ we can directly access it in the form of array. So only the syntactical difference between Java and C++, whatever is there, that is there in this solution, else the logic is completely same. So this is the C++ solution. Let me compile this code. So here we can see even for this, with this code we have got correct output. I'm submitting this solution. So even with this C++ code, we are able to cover all the test cases. So this problem has been solved successfully in both Java and C++ language. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.